dl s hat crossed with E induced. So I'm using cylindrical coordinates, so I can express the induced field as I induced is going to be, I can say some magnitude, and that should be what direction? Negative or positive? How did you decide that? From
The induced will be from counter.
yeah, from Lenz's law, you know, the flux was this value, then it starts to decrease, right? So yeah, so we need an induced magnetic field that points in the same direction. So to get that, we need to have an induced electric field in the positive p direction. So this should be in the p direction. So tau then becomes integral over a closed curve p lambda dl s hat crossed with E induced times p. S crossed p z. So the torque tau becomes p lambda integral over a closed curve of E n times dn in the z hat direction. Now, you know that the electric field is going to be in the p direction, and dl is also in the p direction. So I can write this as tau equals to p lambda integral over a closed curve of the induced electric field dotted with dl. You agree? Along the hat. Because E induced, we say is in the p direction, and dl is, you know, dl, the vector dl is also in the p direction. So I just use a dot product, not multiplication. This is the dot product. When you take the dot product of this, you get that. So what is this? E induced dot dl minus d by dt. So as long as the flux changes, you would have a torque which is given by minus d pi by dt in the z direction. So that means the wheel is going to rotate in a counterclockwise direction. As long as this is rotated. So that shows that there is a rotation. And the second part is to show that the angular momentum imparted to the wheel does not depend how fast you change the flux. Doesn't affect how much angular momentum you are transferring to the wheel. So basically, we have to show that the angular momentum L is independent of time. So how do we relate angular momentum with torque? Angular momentum L is related to torque by what? From a classical you get the torque whenever you change the angular momentum. So this should be change in angular momentum over change in time. Is was responsible for the rotation. So we just show that the torque is given by that. So if I use that, yeah, so if, well, I'm not going to multiply from the moment, but let's try to, yeah, I think yes, dl equals to tau dt, but tau, according to what we have got here, is b lambda d phi by dt, right? So if I substitute that, dl is going to be b lambda minus of d phi by dt times dt. All right? But how can I determine the flux as a function of the magnetic field through this closed conducting loop? What's going to be?
Well, it changes the whole thing, right?
No, just at a given instant of time, before you turn it off, before you turn off the magnetic field, if you want to write phi, how do you write it?
Integral of EVA.
Yeah, it's a constant magnetic field, so I should write B0 times what?
Area, so
The area is covered by the magnetic field is what?
pi a squared.
Pi s squared, yeah. So that's at the initial time. But at any time, let's say b the function of time, that's what actually we are turning off in here. So if I say that's a function of time t, which is, then d phi by dt is going to be what? Pi s squared dB by dt. Now our objective is, whatever angular momentum transferred to the wheel is going to be independent of time. So if I substitute this one in here, what would I get? Okay, so if you substitute this one in here, dl is going to be b lambda. So in place of pi s squared dB by dt, yeah, with the minus sign, pi s squared dB by dt multiplied by dt. Yes.
Is there a minus sign that we're missing?
Where?
Because
Here?
up one.
Here?
Yes.
No,
Okay.
angular.
I thought that was a minus sign.
No. That I wrote it in direct. That's how you define torque, not with the minus sign. Without. So then you have dl equals to pi lambda b a squared dB with the minus sign. So at equals to 0, there is no rotation. So this is going to be from 0 to whatever angular momentum transfer to it, I will call it L. And during this time, what happens to the magnet?